takeaway here is that to generate adult-like pronoun interpretation, behavior, and context, children may need to change both how they represent relevant information from their input and how they deploy those representations. So in one case, the second one that we talked about, children are actually qualitatively different from adults in two basic ways. Children are using accurate representations of information, while adults are using inaccurate ones that turn down the contrast. And children are deploying those representations inaccurately, while adults are deploying them accurately. So development means changing both of these to be adult-like, turning down the contrast on the different information types, smoothing away probability differences, and always deploying that information, always deploying those representations. Now, in the other case, children are actually qualitatively similar to adults. Children are using inaccurate representations in fact the same way that adults are, by smoothing away, by turning down the contrast. And children are deploying those representations accurately in an adult-like way. So in this case, development would mean learning to represent information inaccurately in a more adult-like way, right? Turn up the contrast equally across the relevant information types, but you're not qualitatively changing sort of the nature of the inaccuracy or the fact that you're deploying these representations accurately. An interesting takeaway for me, at least, was that, again, being adult-like doesn't mean being accurate. Right here, the best explanation for adult behavior is representations that are inaccurate because they are smoothing away information. They are, turning down the contrast, right? Now, a question you might ask yourself, I certainly asked myself this: how plausible is that for adult behavior? Well, it turns out that in adult decision-making studies, like from Kahneman and Tversky in 1979, which is a very foundational study in decision-making, adults are known to interpret representations rather than using them accurately. They don't just use them accurately. And in more recent studies, they found limits on what they called the dynamic range of the neural representation of probability, like what the brain is actually seems capable, for whatever reason, of encoding. And in particular, this neural limitation causes endpoints, that is, probabilities near 0 and 1, like say over here. Our morphology points were kind of near 0 and 1, and in fact many of our information types are up in the 0.9s or 0.8s, right? These endpoints get smoothed away into something between the range of 0.16 to 0.80, and in fact that is exactly what these sigma values do. They take all these and they squish them into 0.16 to 0.80. So actually, this is pretty plausible. Adults having inaccurate representations where they smooth away information this amount, right, these sigma values, as it were, is pretty plausible, which is pretty cool. So the bigger picture that I want to leave you with today is that, in general, this case study, I hope, demonstrates how we can use computational cognitive modeling, grounded in empirical data, to better understand how both children and adults can solve complex linguistic tasks like interpreting pronouns in a context that has multiple potentially conflicting cues, and therefore what children need to do to become adult-like. And this helps us better understand, as I said, what children may need to do to become adult-like. And the important thing, again, the interesting thing, is that it seems to be about learning to be inaccurate the adult way, right? So that's pretty cool. And with that, I think we are finished, and thank you so much for listening.